How do water filters physically purify water? Imagine turning on your tap and knowing that the water coming out has been cleaned through a simple yet effective process. Water filters work by physically trapping contaminants as water flows through them. This is a key part of how water utilities make sure the water you drink is safe and clean. Let's look at how this process happens step by step. First, water passes through screens that catch big debris like leaves, sticks, or trash. These screens protect pipes and equipment from damage and clogging. Next, the water moves into a sedimentation basin where gravity causes heavier particles like sand and silt to settle at the bottom. This step removes a lot of suspended solids before the water moves to more detailed filtering. Then, the water flows through beds of granular materials such as sand, gravel, or activated carbon. As water trickles down through these layers, particles larger than the gaps between the grains get trapped. Sand filters are common in city water systems and are good at removing remaining dirt, algae, and some bacteria. Activated carbon filters are especially useful for removing organic compounds that cause bad taste or smell, and some chemicals. Some utilities also use membrane filters, which have tiny pores that block bacteria, viruses, and even some dissolved substances. For example, microfiltration and ultrafiltration membranes have very small holes that only let water molecules and tiny particles pass through. Reverse osmosis is a special process where water is pushed through a membrane that blocks most salts and chemicals, making it very pure. The effectiveness of these filters depends on the size of their pores and the material used. For example, in a sand filter, water flows through layers of sand with different grain sizes, trapping particles larger than the gaps. Activated carbon works by a process called adsorption, where contaminants stick to its surface. Membrane filters act like superfine sieves, allowing only water and tiny substances to pass. Utilities choose different filtration methods based on the source water quality and what they want the water to be like at the tap. For surface water, they usually combine screening, sedimentation, and sand filtration. If taste or odor is a problem, they add activated carbon. For very high purity needs, like recycling water or treating highly contaminated sources, they use membrane systems. To keep everything working well, filters need regular maintenance. Screens are cleaned to prevent clogging. Sand and carbon filters are backwashed, which means reversing the flow to flush out trapped particles. Membranes might need cleaning or replacing if they become clogged. Utilities constantly monitor filter performance to ensure water meets safety standards. So, in simple terms, physical water purification is about barriers and porous materials blocking or trapping contaminants. It starts with coarse screens, moves through sedimentation and media filters, and sometimes includes advanced membranes for extra purity. Each step is chosen based on the water source and the quality needed, with ongoing care to keep the water safe and clean for everyone.